Hey kids, Flexing Teacher Weber here. This is the second video for investigating right triangles, and this is going to build on what we learned in the first video. In the first video, we learned how to count the area of squares, and we're going to use this idea for your assignment today. So in your assignment today, you're going to be making a chart like this, where you are going to be calculating the area of some squares. Now let me show you what I mean. This will end up being on your assignment today. So I'm going to flip over. Your assignment's going to include this page. And it's going to include these diagrams. And I want to focus in on diagram number 1. You'll notice on diagram number 1, we have a right triangle. Okay? There's the right angle. This side would be called the horizontal leg. This would be the vertical leg. And this would be the square. This right here would be the hypotenuse. Now, because the hypotenuse is always opposite the right angle. Now you'll notice that we have a square connected to each leg. There's a square connected to the horizontal leg. There's a square connected to the vertical leg. And there's a square connected to the hypotenuse. Now what you're going to do in this activity, you have a total of 5 of these diagrams. So you're going to make this chart with 5 different triangles. And you're going to calculate the area of the square of the hypotenuse. You're going to calculate the area of the square on the horizontal leg. And you're going to calculate the area of the square on the vertical leg. And hopefully, you're going to discover some sort of pattern. So I'm going to do the first one for you. So I'm going to go to the first triangle, and I'm going to start with the square on the hypotenuse. The square on the hypotenuse is this one right here. And we want to calculate the area of this square. So remember what I was doing? This square is divided into 4 right triangles. Now what I'm going to do is I'm going to connect one of those right triangles onto the hypotenuse of another one so that we get a rectangle. So I'm going to do this. So now I've got 2 of those right triangles that make up that square. I've connected them together. And now I can count up the area of those 2 right triangles without having to count up half squares. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 2 of those triangles would be 12. Another 2 would be 12, that's 24. Plus the 1 is 25. So the area of this square on the hypotenuse is 25. I'm going to write that in my chart. Now I'm going to calculate the area of this square on the horizontal leg. So I'm going to go back to the diagram, and I want to calculate the area of the square on the horizontal leg. Well, this one's easy. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the area of the square on the horizontal leg will be 16. And then I'm going to go back and I'm going to do the area of the square on the vertical leg, this one right here. And that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to go back to my chart, and the area of the square on the vertical leg is 9. So on the assignment I give you today, you're going to do this exact thing. I've already done number 1 for you. You're going to do 2, 3, 4, and 5, right? Because there's a total of 5 diagrams there. So you're going to do those 5 diagrams. But then the big thing is you want to see if you can find a pattern. Okay? I'm going to get you to ask yourself this question. What is the pattern between the area of the squares on the legs and the area of the square on the hypotenuse? I want you to look for that pattern and see if you can figure that out. And if you figure that out, you've discovered one of the most important mathematics things ever. Okay, so that's your goal for today, is to complete that assignment like I've just outlined and see if you can discover that pattern. That's all for today. We'll correct this assignment tomorrow and study this in further detail. Flexing Teacher Weber, out.